Hello everyone and welcome to my channel DLD Quest. I am thrilled to have you here. In this series, we are going to dive deep into digital logic design DLD, starting from the very basics in Unit 1 and covering the entire syllabus step by step. Whether you are a beginner or looking to strengthen your understanding, these lectures will guide you through every concept in a single and comprehensive way. So, get ready to explore the fascinating world of digital logic design with me. Make sure to subscribe and hit the notification bell so you don't miss any updates. Let's get started. Welcome to the first lecture from Digital Logic Design. The topic is number systems. In this number systems topic, as we know, there are different types of number systems. The first one is binary, second decimal, octal, hexadecimal, radix 5, radix 7, radix 12, like this. Binary means pi means 2. So in this binary, we should use only 2 digits. First of all, number means combination of digits represent a number. So to write the binary number, we should use only zeros and ones as digits. Totally 2 digits we have. That's why the radix of a binary number system is 2. Radix means this is the base value of a number system, which is consisting of the total number of digits used in that particular number system, including 0. 0 and 1, these are the digits. Always the number of digits should start from 0 only for every number system. So here only 2. So that the radix is 2. In the same way, for decimal number system, we should use only 0 to 9. These are the 10 digits totally. So radix is 10. For octal number system, 0 to 7. That's why radix is 8. For hexadecimal, hexa means 6, deci means 10. So that 6 plus 10 is 16. Therefore, 0 to 9, these are decimal digits. After that, we should use only alphabetic letters. A to F. So totally 16 digits we have. So radix is 16. In the same way, suppose if we take the number of digits only from 0 to 4, any number, that number system we call it as radix 5 number system. Suppose if the number of digits should take only from 0 to 6, then we call it as radix 7 number system. Similarly, 0 to B. 0 to B means 0 to 9, 10 plus A equal to 10, B is 11. This type of number system is radix 12 number system. Here the binary number should be represented as 0101 with base 2. This is a valid number. Suppose if you take the binary number as 1021 with base 2, this is invalid representation because 2 is not at all binary digit. That's why it is invalid representation. This is correct, this is wrong. Okay. Similarly, for decimal number system, each digit in this given number should lie only between 0 to 9 with the base 10. So this is a valid number. Here B and A also is there, so that this is not a valid number because alphabetic letters also in this number with the base 10. Similarly, for octal number system, each digit in this number should lie between 0 to 7 only. So here 2674, this is valid number. Here it is 2684. 8 is not at all octal digit. That's why it is invalid number representation. In the same way, hexadecimal means 0 to 9, A to F. Therefore, this is a valid representation. Whereas here, G is not at all hexadecimal digit. That's why it is an invalid representation. 0 to 4 only we should use for this radix 5. Here, when we see this one, 2413 is a valid number. Whereas 2453, it is an invalid number because 5 is not at all radix 5 digit. Similarly, 0 to 6 for radix 7 number system, it is a valid number representation. Whereas here 7 is not a radix 7 digit, that's why it is invalid representation. Radix 12. Here also these two are radix 12 digits, so that this is the valid representation. Here D is not a radix 12 digit, so that it is invalid representation. In this way, you should try to write several valid numbers and several invalid numbers, because in some problems they may ask, is this given number is valid or not? Then you should find easily the given number is valid or not. Okay, so these are the types of number systems. These number systems should be represented in 2 ways. The first category is integer type. Second category is floating type. Integer representation means corresponding number system digits to represent a number. Whereas in floating type representation, we should use the decimal point. Before decimal point, we called it as integer part. After decimal, we should call it as integer part. For any kind of representation, if we use the decimal point, then we should identify the given numbers should be in floating type form. Let us see different examples. The first one, 42789.312 with base 10. This is a decimal number system. In this, before decimal point, we called it as integer part. After decimal point, this part is called as fractional part. Similarly, suppose if you take the hexadecimal number system number, in this also, before decimal part, the whole underlined part is integer part. After decimal part, underlined part is fractional part with the base is 16. So this is the way of representing the floating point representation. In this way, everyone should try to write your own numbers in integer form and floating form. If you like this concept, please like, share and subscribe to my channel and click on notification bell to get more updates. Thank you.